Okay, so I'm going to go over a little bit more about the multiplexers. So this is the Boolean expression. You're going to write your ones and zeros and figure out what your minterms are. When you figure out what your minterms, you're going to wire your minterms on the 74150 to ground. Because it has the inverter bubble, the output will be high. So if you put it to ground and you want a high, that's how it works. If it did not have the inverter bubble on the output, you would have to tie your minterms high. So you're going to go through this. You're going to figure out what your minterms are. Then you're going to wire up your multiplexer. This is the diagram of the multiplexer that is in the lab and that's in Multisim. So it has 0 to 15 and their prospective pin numbers. The A, B, C, D are the inputs, which is your selects. And then you have pin 10 is your output with the bubble. So let's say if you had 5 as one of your minterms, then pin 2 would be tied low. So when these are selected to put your binary 5, you would get a high out. Okay, I personally like this one better, and I actually added this into handouts. So this is pins 12 and then 13 to 24 going up. These are your data inputs, which is E0, 1, 2, 3, 4, 5, 7, all the way up to 15. Your data selects, S0, S1, S2, and S3 are pins 15, 14, 13, and 11. This pin has a strobe. The strobe is only activated and will activate your 74150 when you put pin 9 to ground. Pin 12 is your regular ground, and then VCC is pin 24. You have to put that to 5 volts, okay? Your data select, D is your most significant bit and A is your least significant bit. So when you wire up your output, or your inputs, you can wire it up to least significant to most significant, or most significant to least significant. It's up to you how you want to portray them. Then you're going to go and you're going to do it on Multisim. And so, like I said, this is the 74150 multiplexer. You're going to put your pin numbers for your minterms on to ground. Everything else is going to be to 5 volts. Your output is going to go here on your logic converter, and you can find that on the right side in Multisim. Just kind of follow the little tools down and you'll find the logic converter. S0, 1, 2, 3, these are going to be hooked up here. What you're basically doing is you're going to verify your truth table. So when you hit 0, 0, 0, are you going to get a high or a low? So your minterms should have a high. Everything else should have a low. So you're going to verify your truth table by wiring up your circuit or your multiplexer, and then you're going to also do it on Multisim to verify the truth table. So the truth table of the multiplexer could be found in the logics, and then you could just do a search for 74150. You should have the data sheet for the 74150 in the handouts as well. Look through that. It tells you a little bit about the strobe. This is this is the logic involved inside the multiplexer, and this is what we'd have to wire up to get the same that we are doing with one chip. So thank God we have the multiplexer and we don't actually have to wire all these up. And then what else I got? Yeah, here's more of the data sheet. So that was on the data sheet. It gives you a little explanation. So again, this is what you're going to wire up for Multisim. And you're going to verify the truth table. right here. And that's basically it when you're talking about multiplexers. Okay, good luck. Bye-bye.